On this episode of Change Mode, we talk about functions, functors, and other F words we can't even say with special guest Tom Crescenzi. You won't want to miss this one. This is Change Mode, episode number 3, recorded May 14th, 2014. Kicked in the Monads. Hello and welcome to this week's episode of the Change Mode Show. My name is Dan, and with me, as always, is my co-host Colby. Colby, say hi and wave.
Hi.
And this week we have a special guest, Tom Crescenzi.
Hello.
Tom, would you like to introduce yourself as a first-time member of this show?
Sure. So I went to school with Colby and Dan, and I currently work as a software engineer at FactSet. Other than that, I can't think of many more interesting things to say.
Cool.
What's FactSet?
Before we answer that question, this week's topic is functional programming, and before we get into that, I'm going to plug a few things real quick. This show is on the Coffee and Beer podcast network at coffeeandbeer.tv. The show's actual website is coffeeandbeer.tv/change mode. You can go there to see all the current episodes, past episodes, show notes, things like that. As part of the network launch, Coffee and Beer is running a giveaway. So if you go to coffeeandbeer.tv/giveaway, GIVEAWAY, and enter the code when prompted, FUNCTOR, FUNCTOR, then you can be entered to win some fabulous prizes, t-shirts, mugs, with all of your favorite coffeeandbeer.tv show names. So with that out of the way, let's dive right into functional programming. So, Tom is our guest, our resident functional programming aficionado.
Oh no.
And the first question, I think, is what is a function? So I think Tom probably has a really good actual answer for this, but I'm curious what Colby's answer is, as long as he hasn't already read Tom's answer.
I did, but I don't remember what it was.
Okay, good.
A function is like it's like behavior, a block of behavior that you can reuse over and over again.
Okay.
As many times as you want.
Tom, what is an actual function? Does the function have to do with like the functions we use in math?
Right. Well, I guess the big thing is that in computer science we talk about like people use the terms like method and function generally interchangeably, or like subroutine. But when we're talking about functional programming, you mean more like a mathematical function. And I just copied down the wiki definition. And
I thought you wrote that yourself.
No, I'm not cool enough to write that myself.
Oh, I see here, yeah. Okay.
We've been had.
No, I mean, this way I can say it, and then no one will have any idea what's going on. But in mathematics, a function is a relation between a set of inputs and a set of permissible outputs with the property that each is related to exactly one output. So really all that means is that if you give it something, it's always going to give you the same thing on the other side. And it might be transformed, there might have been some operations on it, there could have been, as Colby said, a bunch of different things done to it, but it's always going to be the same output.
So it's deterministic.
Basically it maps inputs to outputs. And that's the big difference between like a function and a method, because methods aren't necessarily deterministic.
Interesting. I wasn't aware of that distinction, actually.
What?
I wasn't aware of that distinction, that a function had to be deterministic. I guess that's true in the purest sense, like
right.
The Atlantis utopian world of computer science that none of us live in.
the world of Haskell, or languages like that.
Right. Okay, cool. So, if that's a function, then what is functional programming? And I imagine that many people watching the show who have gone or are going through a computer science program hopefully will have had some exposure to functional programming. So I think this is mostly just a formality. but what is functional programming?
Who is that? Is that for me?
It can be for you. It's for you now. You spoke first.
All right. Really, I mean, there's some stupid definition that's really formal, but it's basically just expressing computation as a series of functions, which I said that and it ended up being a lot more formal than I was expecting it to be. But really, as opposed to something, well, I guess we're getting ahead of ourselves, but yeah, functional programming.
No, segue away, my friend.
All right. So as opposed to something like object-oriented programming where you express computation through objects, in functional programming, you're primarily expressing computation through functions. And these functions, when we're talking about functional programming, is in a deterministic sense.
Interesting. So you talked about the difference between functional programming and object-oriented programming, but there are other kinds of programming that it is also distinct from. The like taxonomy of programming languages is really bizarre, right? There's functional programming, and then other people say that there's functional programming and there's object-oriented programming, and that's it. But that isn't true. I found out this week that Perl isn't object-oriented. It's just imperative. And imperative is the style... Colby, do you know what imperative is?
I would assume imperative is just like one thing at a time, like, I don't know, like entirely procedural? Or
procedural. Maybe... What is the difference between imperative and procedural? I don't know.
That's a good question.
I'm not sure. I'm not sure what imperative means. I guess in my head they mean the same thing because I just made that connection, right?
Interesting. There's, of course, an excellent Stack Overflow question that appears to answer this.
Yeah, so imperative programming is like the recipe, right? Like whenever people are like, oh, like programming is like a cookbook, right? Like you say you do this, then you do this, and then you wait 5 minutes and while you mix everything up and then finish by pouring on top of noodles. Right. So the big difference between imperative, generally functional languages are declarative, which declarative you say this is what you should do, not this is what you should do, and this is what I want done, but not necessarily how I want it done. So
wait. Declarative is where you say this is what you should do, and then this is also how you should do it. But non-declarative would be something like prologue, where you don't describe.
Prologue is declarative. Prologue is absolutely declarative, because you're just saying this is what I want done, and I don't really care how you do it. But imperative is I'm going to describe exactly what should be done.
Oh, okay.
Yeah.
Makes sense.
Cool.
So, we got functional programming. We know what it is. We know that it's distinct from object-oriented programming and declarative programming and all of these other things. What advantage and disadvantages are there to functional programming? I'll throw one out there right now. It's really hard to do.
Yeah,
hard is
that's
relative,
kind of
though.
a devil's advocate answer that I'm open to being disproven on, and I might not believe it myself.
I think it's one of those things, though, where it depends upon what you mean by hard. Like, if it's conceptually difficult to understand, like object-oriented was conceptually difficult at one point for you to understand, probably.
That's true.
Yeah.
I wonder if it's only hard because the first programming we did was was more procedural.
Yeah, at MIT they teach scheme first, I think.
That's bold.
Sounds scary.
Well, so I think we've all had some experience with functional languages, and we'll come back to this. I did Erlang first, and that was really cool, and then that transformed into Elixir. I've also done Scala, but we can talk about that later. What are y'all's functional programming experience in terms of technologies?
Well, we did what, scheme in
Oh yeah.
languages.
I forgot about that. That too.
So
Which is a
It's like
Lisp dialect.
Wasn't it
Yes.
like a build your own scheme thing?
It was
sort
a
of. It was like,
build your own language using scheme.
yeah. That was very confusing because not only did we not understand how we were building our own language, but we also didn't really understand the language we were building it in.
True facts.
And also, I dabbled a bit in Haskell at one point, and then
That's
stopped.
dangerous. Haskell's a gateway drug.
You know, I didn't get
during
to,
your rebellious teenage programmer years.
I guess so, yeah. I also write JavaScript all the time.
Interesting. And JavaScript is a functional language?
No, but it's not functional. It has functional properties.
Interesting.
It's one of those weird in-betweens.
What are those functional properties?
It has first-class functions, so means like functions that you can pass around as values. So like in the same way you would assign a variable to a string in a language like Java, you can assign a function to a variable and like pass it around. You could pass a function to another function and call it or not call it or do crazy stuff like that. So
Can you partially apply functions in JavaScript? I don't know if that's getting ahead of us
yeah.
ourselves.
Well, what does that mean? Because I still don't know.
So I think the example that I was saying earlier, it's almost kind of like piping in Unix. So you're essentially saying like if you pipe like who grep Dan or something like that, like who pipe grep Dan, you're essentially saying I have grep Dan as like a unit and I want to put another thing on the end of it, except it's not quite right. But you're essentially creating functions that haven't been finished yet. And you're saying that you only need one more argument. Let's say if you have two and you already give it one. So if you have like plus, you could do like 5 plus and then pass that around. And like in like JavaScript, I don't know how would that work, hold me in JavaScript as an example.
So you can use the bind method, like, so Dan, the way I would explain it is that you're like pre-filling in one of the arguments to the function and then passing around a function that has that argument filled in.
Oh. Gotcha.
That is a better way to describe it.
So in JavaScript, you can use the bind method. So all functions in modern JavaScript environments have a method called bind. So you call .bind, and you can apply a scope. So that's a topic for a different day, for a JavaScript day probably. But then after the scope, you can also apply variables. So or apply values that are applied to the function in the order that they're passed into bind.
Nifty.
Yeah. And then so bind returns a new function with those arguments applied to it.
Gotcha.
So you could do like sum and bind 5 to it and set it equal to like 5 sum, and then you can call 5 sum 2 and you'll get 7 back.
Yes.
Makes sense. So Tom, what's your history with functional programming?
So I started, I guess, with Lisp, and it was really confusing, and I didn't get it. And then
You started with Lisp?
yeah, that was my first real exposure to functional stuff.
Nice.
I was like, this makes no sense at all, and there's all these parentheses, and what's going on? And then, like, right at the end, like, right after the assignment was due, I finally realized what was going on, but then I never touched it again. And then I took a Scala class, which was interesting, because Scala is a weird beast, because it's kind of like everything. I don't even know if I would call Scala all that functional.
I've heard Scala described as like vegetarian pork.
That's a great way to put it.
Tries to be everything to everyone.
Yep. Yeah, and then my big functional experience was writing a compiler in Haskell. And it wasn't even, I mean, I can say that, but I look back at it now and it's like, I didn't even write this correctly, really, right? Like it was functional kind of, but a lot of it was more of just me hacking at it to get it before the deadline. But that was a really cool experience because it...
Can't we say that about all code that we've written looking back at it?
That's pretty true.
Hacking before the deadline.
I like to think that I understand things sometimes, though.
Yeah,
sometimes.
You like to think that. And then you peel back a layer of abstraction and
Right.
Yes, no longer
the
understand.
emperor wears no clothes.
I think I understand things just enough to make a big mess.
Fair enough. Okay, so you've got Haskell, JavaScript, Erlang, Elixir. Okay, where were we before this? Oh yeah, advantages and disadvantages. So, and specifically comparing it to the, I think it's fair to say that the majority of programming languages are OO these days. At least the majority of ones that are used in industry and stuff.
Yeah, that's pretty fair.
I guess if you don't count JavaScript as OO, though, that might be less true in terms of lines of code being written today.
Is PHP OO?
Yeah.
Yeah.
All right.
It's like Perl, but then you actually encoded an OO into it later on. It's actually not the worst. Having used Perl and JavaScript now, the object system is just, it's almost amazing compared to those.
Mm.
I feel like PHP has a very reasonable, like, very traditional and reasonable object system
Totally.
when compared to, like, JavaScript. Or I would imagine Perl, which I've never used before.
It's an experience. So in what situations, and I guess we should make the distinction at this point, there's functional programming languages, and then there's writing code in a functional way, which you can do in any language with sufficient self-discipline.
In most languages, yeah.
And what language couldn't you do it?
I want to say that you'd be hard-pressed to do it in C, but I'd assume that there are function pointers, so you probably could.
Yeah, there have to be function pointers.
Yeah, that's true. Yeah, you can definitely take a reference to a function in C. I do it all the time in C++.
Yeah. So,
It's terrifying.
in what situations would you reach for functional programming or OO? Like, recently, what sort of things have jumped out at you? And then I will throw a curveball.
So I'd say anything that is structured mathematically. If you're operating over lists or if you're doing math, anything with data structures too, I would really say, like Lisp, right? List processing. It's functional programming is great at that. Mapreduce, that's functional. If you've ever mapreduced, you've functional programmed or programmed functionally.
What is Mapreduce?
Colby, you love that.
So map and reduce are two different things. So map is the traditional name for a function that, or for an operation which takes a list of items and applies a function, one function to every item in the list, and then returns a new list of the exact same length comprised of the results of each item as it's passed into the function. And reduce is like when you take a list and apply a function to it such that you reduce the list into one value.
Cool.
So if you've ever used fold too, if you don't, that's the same thing as reduce.
Right. Yeah.
Yeah. Oh, yeah.
So when you have lists and you're mutating the list in place, it's usually a good time to reach for something functional.
Although usually in functional, it's not actually in place because stuff is typically constant.
Yes, so that's a good point. Why are functional languages usually have this immutable variable property?
That's a good question. I
I
think
believe
a
the
lot of
answer is the term referential transparency.
Okay.
And I don't entirely remember what that means. This is my seems like a good term to use to describe something. An expression is said to be referentially transparent if it can be replaced with its value without changing the behavior of a program. In other words, yielding a program that has the same effects and output on the same input. It doesn't really tell us anything at all.
Okay, so that's why in functional programming you have this strict function definition, right? Because if you have a function that's always going to take the same thing and give the same output, it's referentially transparent because you could just take the output and remove the function.
And if you could change the value of the thing that you passed in while it's happening, that would break that referential transparency. I cannot.
Right, you can't have mutable state.
Transparency. Yeah.
Right.
Cool. So that brings to mind an interesting downside. It's probably the hardest part of functional programming is not having mutable state. Something like a for loop just becomes kind of difficult. So anytime you're trying to keep track of points, like a score, anything like that is really, it's doable. It's just difficult to think about when you start from the point of add 1 to this variable and store it back on the same variable. Which is, I don't know, is that a downside? Or is
not
that
having state?
Yeah. Well, you do have state.
Right.
So you end up having state by recursively calling functions from within each other and passing in an updated value. So instead of saying a equals a plus 1, you'll be like self a plus 1. And now the next time that function is called, you get 2 if it started at a equals 1 instead of 1. So you do have state.
But you don't have state in the sense that, trying to come up with a good example, I don't know. I can't come up with a good example as to why that's really terrible. I can come up with a lot of examples as to why not having state is good.
Sure, what are those?
Well, so right now, one of the big things I'm actually working on is making a bunch of stuff thread safe. And it was originally C, and now it's C++. And sometimes there are just global state variables hanging out that are going to be process-wide. And you can't have a process-wide global state variable that, like a very non-constant, if it's going to be thread safe.
Yeah.
Well, you can, and it requires locking and all of those sorts of things, but it's a lot easier if you don't, because you don't have to lock, right? Because if you never have state, then nothing can try to edit something else at the same time.
So that's a reason why a lot of functional languages are really good at concurrency. Erlang being the standout, like all full steam ahead on that thing, but most functional languages, if you have a function and it has this referential transparency property where given the same input, it always gives the same output, and it has no state outside of its own kind of function list, if you think of it like that, outside of its own stack, then you can take a whole bunch of data that you're, say, mapping over and just split it up arbitrarily onto many machines or many cores or many threads and do it, and you know that it's thread safe because there's no state shared outside of these things.
That's why Mapreduce became so big.
Right.
Because you could just say, okay, well, I have 1,000 cores and I'm going to put 100 elements of this gigantic array on each core, map over them, and then reduce them all from the core, or from each core.
Yeah. Colby, do you find yourself reaching to do functional-ish programming in your day-to-day?
Sometimes. I mean, it ends up being pretty easy to do in JavaScript. Like, I map stuff all the time. I don't reduce that often, but I map a lot. Especially, like, So writing React, or even just in general writing regular JavaScript, map is a pretty useful thing, because like usually you have some list of values that you want to turn into some list of DOM nodes. So it ends up being a pretty easy solution to that problem. Further than that, less so. I mean, we write pretty like object-oriented JavaScript at Facebook, so.
Yeah. One of the things I find myself doing is, for example, I worked on this project with my manager for a day that was a Python script to orchestrate rollouts of new infrastructure. So one of the things the ops people have us do, if we're changing like an Apache config or installing a new package, install it 10 machines at a time and slowly roll it out. Install it 10 machines at a time, look at the graph. Another 10, look at the graph. So we were writing the script to automate this, because before you had to do all the steps manually. You had to update the configuration management, SSH out a command to all the machines, usually to restart so they'd pick up the change or whatever. It was a mess. So we end up writing this Python script, and Python is decidedly OO-ish and imperative. But what we ended up with was kind of a main method that was just functions chained together, and we didn't actually chain them together, but we took the output and assigned it into a variable, and then we passed that into the next thing. And so our main method kind of read like English. It was take the command line input, parse it, take those parse things and pass them into this thing, take the output from that thing and pass it into this thing, and all of those things had like discrete names. Shell out, or SSH out command, update chef, all these things, and it made it really easy to read. And and this wasn't OO, there were no objects, but these functions, all of their input was dependency injected, or in other words, they were referentially transparent. And so it was functional programming in a non-functional language, though I do know that Python people do functional programming an awful lot. And the list things in Python are amazing. What are the list comprehensions?
Oh, list comprehensions are sweet.
Yeah.
Yeah. List comprehensions, though, can just be defined as map. So you could write like a macro like in Lisp and create your own list comprehension.
That's when you know you're having a good time.
Yeah.
Okay, so here's the curveball that I alluded to. I posit that writing good OO code is indistinguishable from functional programming.
What do you
Here's
mean?
why I say that. So, good OO code follows the solid principles, single responsibility, blah, 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 blah. The big one is dependency injection, which is essentially referential transparency. I cannot say that word tonight. So, dependency injection is all of the things that your object needs get passed into the constructor. So, your database client, references to all of the external libraries and objects you're using get passed in instead of instantiated inside. This offers a lot of testing benefits because you don't need to like have a database standing up to run your test. You can just mock out the responses from the database or whatever. Even better, you don't pass the database and you just pass in the data that it would have given you, and you do that somewhere else. So you end up, at the end of the day, in an ideal world, if you're doing it right, you end up with these balls of code that are referentially transparent. They take in data and they give out data.
But are they actually, though?
I think that if you're doing it right, you pass in data, it gets internalized as internal state in these objects.
So I think that's the key there, though, is that there is internal state.
But so there's internal state, I think, belying all functional programming. So at least in Erlang, this is what ends up happening. And really, Erlang was my big break into how to write OO well. So in Erlang, you have these actors, which are modules of functions, basically just a collection of functions, and each actor can be run independently from every other, and you communicate with them with this message box idea. So you send messages. The actors can ingest these messages and do things with them. So you could send a message to something that would send an HTTP request. It would take the message to send the request, and it has in that message the data that you want to send, and it sends it. Another good example is, I learned this recently in Erlang, you want to take your state and move it out into their own actors. So if you have a module that implements some sort of stack thing, so it has internal state and it behaves like a stack, take that and move it out into its own module that the behavior speaks to. So the behavior manages when to pull and or push and pop from the stack. The stack is somewhere else and is self-contained, and the actor that handles the behavior can die over and over again, can crash however much it wants, and your state is still safe. Your state is so isolated and so stupid that it's never going to fail.
So I think that's the big difference between objects, though, is that objects bundle state and functions.
That's where the single responsibility principle saves the day. I'm not convinced that this was the way it was supposed to be, that objects are supposed to have data and behavior. I know we're told that. I'm not convinced that it's the right way. Imagine if you took the Erlang approach to objects and you had your data object that gets dependency injected into the behavior object, and the behavior object doesn't care. It's a black box. It doesn't have any state at that point. It's just behavior, and this only little tiny thing has an internal array that it controls. Yeah, just... So when I think about doing OO well, I usually try to think about being as functional as I can, because at the end of the day, Alan Kay with OO was talking about, oh, these objects are going to be cells like in a human body, and they'll just pass messages between one another, and they'll be black boxes to one another, and you don't care, and they'll be very small and single purpose and specialized to what they do, but you'll have many of them. It feels a lot more like objects to me, or a lot more like functional programming than the typical OO, where you end up with these God objects that instantiate 15 things inside of the constructor that aren't passed in, and have all of this state and stuff.
Mm-hmm. I think the big issue, though, is that you can still, like, especially with the cell example, right? So if a cell is talking to two different cells at the same time, its state could potentially end up being different, and even though one cell says, hey, the other cell, because the other cell said something different, could respond in, like, a different language or something like that. Where, like, 2 plus 2 might not always equal 2 if the plus function relies upon some sort of internal state.
Sure.
So
is there a more concrete example with a more complicated data structure? So instead of just storing a number, what if we had like a stack?
Okay.
Is there an analogous problem?
So if the object contains a stack, I'm trying to think. Stacks are very, very simple, but you could have, like, even if it... Come back to me. I'll come up with an example. I'm trying to come up with a good example as to why that's not the case.
Colby, do you have any thoughts on my crackpot theories?
I think, like... I guess it's the I don't know if I can actually explain this, but it's the, like...
We can laugh at you as you try, so either way it's entertaining.
Okay. I'm willing to entertain the possibility that you could write OO that is effectively functional. However,
absolutely. I think that you could. I don't think that you couldn't.
Right.
I think that it's not that it wouldn't be good OO if you did.
Yeah, and I think it's the thing that differentiates it is that, I mean, it's just that an object can have state at all, right? Like I think of functional programming as you have data and you turn the data into some other data without changing any data, and that, like, at every micro level of your process, you're going from some data to other data. And, like, whereas when I think of, like, not even when I hypothetically think of OO, when I recall OO that I've written and read in the past, frequently that is not the case in your modeling.
But in any sufficiently complicated functional program, this could just be the Erlang bias in my background, but don't there end up being, like, partitioned bits that talk to one another and that do end up keeping state throughout the runtime of the program?
Well, so, like, in my compiler, for example, because I didn't really leverage the concept of monads because I didn't really have the time to completely understand them. It was really purely functional. So basically all it did was it took a long line of text, right? So it took this programming language, consumed it, and spit out the binary.
Sure.
So there was never any state. It just kept getting passed from step to step as something that had been transformed.
Right.
And you could replace an entire step with, like, this is the referential transparency bit. You could replace all of parse with just the output from parse, and you would get an identical program.
Yeah.
Or an
that
identical
works really well for programs that run and then complete.
Yeah,
I'm talking about, not necessarily a web server, but you can write a program that keeps state over the time in a functional language. Any functional language, you could write a scoreboard program, right? Where you send it messages and it updates scores, and you ask for what the person's score is, and it tells you what it is.
Right. But then it becomes potentially impure.
Okay.
So, like, I/O, even in, like, Haskell, for example, adds impurity to the whole thing. Because if you have I/O in a function, it could read in something different a second time, and it would have a different output. So it's not referentially transparent anymore because there's I/O inside of the function.
Yeah. But if you isolated that to one part, then everything upstream of it would be referentially transparent, right?
Right. So that's almost the idea of a monad. I feel like you're getting towards the idea of a monad, where you have these discrete transformations of data, and you say, I'm going to have this. I'm going to do a bunch of stuff to the data, but I'm going to give you this in the end. Like, I'm definitely going to give you a string. That's kind of like the idea of monad. But you're going to do a few transformations and stuff in the middle.
So can you try and explain a monad?
I really like...
I think this means we've made it as a programming show. We're talking about monads now.
It's like the hip new thing to do is to talk about monads. The way that I envision them is it's almost like, I have no idea if this is correct, so someone could potentially just be like, oh, this is totally wrong. But it's kind of like what I was just describing, where it models a set of transformations and guarantees a specific output that's going to be pure, but it doesn't necessarily guarantee what's going on inside.
Is that output kind of a schema? So, like, it will have these many fields, and these fields will be of these types?
Mm-hmm. Yeah.
Gotcha.
You could say
so
that.
It's almost like something, I don't know, like thrift or protocol buffers, where you have this contract that says you don't know what happens behind this thing, but on the way, what you're going to get is a thing we're calling this, and it has like this integer field, and then these string fields, and they're called this, and we guarantee that these will exist when you call this function.
Right, I don't actually know. Yeah, that sounds right from what I've read and from how I've used them, but I don't really know how they work under the hood. I think that's the mystical part.
There always has to be some mysticism when you're programming. You just light an incense and dim the lights.
I mean, if you actually knew what you were doing, it wouldn't be fun, right?
Right. There would be no element of danger left.
I should tell myself that every day.
Yeah.
But I think after having worked on, right, because I've essentially now been working on a programming language for a year. So I should elaborate a little bit. My day job is working on an internal programming language. It's kind of like a query language mixed with a scripting language, so it's kind of terrifying. But after having worked on it for as long as I have, I think I really understand the workings of like a procedural language. However, when it comes to functional, I could absolutely not tell you what a monad is, or like how it actually works. I could use it. I could write code that leverages a monad, but I could not tell you how it works. However, I could write C code, and I could tell you probably how it works.
Okay, so I have a concrete example about your compiler that you wrote. So I don't know if you did this, but you might probably want to keep state on which line of the source code you're currently processing. Mm-hmm. So if there's a syntax error or some other compile time type mismatch, something, you can say, hey, there was an error on this token on line X. Mm-hmm. That state, is that state that you would make so that it's passed in and then a function consumes each line of the source code? Or is that state kept separately in the function that iterates over every line, or the function that's called on every line updates that as like a callback when it's done? Like, okay, did this pass? Yes, now we're on line 13.
Right, so like the callback example wouldn't be referentially transparent.
Okay.
But the way that I did it, or like take my Lexer for example, it was basically just a set of folds. So you said fold over this set of text, and I passed in the function that you were folding, then folded over the line. So it was lines, and then fold over each line with like break on spaces, and you could get each time that you were done on a line, it incremented the number by 1. And then each time you were done on a word, it incremented the number by 1. So you could say, okay, well, I'm on line 20, word 5, or something like that. Here's where your error is. But none of it ever reached outside. The whole thing was just a single, essentially it was just a map and reduce for most of it.
Right. So you're using like closures to like keep your state in your function.
Right. So, yeah. Yep. Yeah, I like it's exactly like that. It's like I got big things and it keeps getting smaller. Well, and like another thing with so I couldn't use pointers, right? Like there's no pointers. So for a tree, you can't say, because you need like a parse tree. You can't say something like, the children of this plus are 2 and 3, because you can't have a plus object that contains a 2 and a 3. All you can have are nested arrays, essentially. So the way that I did it was the whole thing was recursive, and as it unfolded, as the recursion unfolded, it built the tree up. So you would have an array, so like if you had plus, it would call plus, and then it would say, okay, well, what are its children? So it would call 2 and 3, and those would be integers. And then the return values of the integers would be added to the plus as children of the plus. But it was actually just being concatenated into a single giant array that kept getting bigger as it was getting passed back up.
Interesting.
I don't know if that makes any sense. It's not particularly
I think it does, but I'm not sure I understand.
Basically, instead of adding, so if I were to do it in like C, it would probably be easier to add these pieces into the tree as I went, right? Like you could message and say, oh, here's a plus, right? Like message the tree and say, okay, add plus node, add minus node, add 2, 3, and 6, or something like that. But instead, since the whole thing was essentially just a bunch of functions that could unravel and you'd have the same value, the functions plus would call like left and right, and then take left and right and add them into an array. So I just kept increasing the size of this array. I'm probably clear as mud, but it also doesn't help that I wrote this a year ago. So
that's fair. No, I think I understand. It probably also doesn't help that like neither Dan or I took compilers.
I took a crash course in compilers the past few months, though.
Oh, cool. Well, that's more than I can say.
It's cool stuff.
Yeah.
Yeah. I wanted to write a JavaScript interpreter in JavaScript.
Interpreter is interesting. That's what I work on. And it's different, quite different from a compiler, but not really.
How so?
Well, interpreters keep state. Compilers don't. It's like when you enter like
that's true.
The Ruby REPL or like the JavaScript console and you say x equals 2 and then you do a bunch of stuff for 6 hours and you come back to x, well, that reference might, if you hadn't touched x, that reference will still exist.
But that'll be the same in a compiler if you had just typed out all the same code into a file.
True.
I'm still trying to come up with a good example as to why objects are not. So you can definitely write an object that is guaranteed to be referentially transparent. But if an object keeps state, I think a good example is random. Random is something that's really, really hard to do functionally.
Well,
right,
wouldn't you just have to pass in the right seed?
Well, random is absolutely not referential. Random is by definition not referentially transparent.
But it should be referentially transparent given the same seed, right?
Well, that's not. If you use a seed to create a random number, it's not actually random, then, is it?
True.
So getting true random is an example of something that's really hard to do without state. I don't actually know how they do it in like Haskell.
It's possible?
I have no idea. That's a good question.
Okay. I would think it wouldn't be possible.
I would assume that it would be an IO call, kind of. Like it would be impure in the same sense that IO is impure. But like if you have a power object, right, and the object, you pass in a number and it raises it to the power that's stored inside of the object, let's say. So you can create like power 2, and then you can pass in 3, and you'll get 9. So every number that you pass into power will give you it raised to the power that you instantiated that power object with. Does that sound like a fair object example?
Yeah, it does.
So in that case, you can call power 3, and the state inside of that object could be anything. You have no idea what you're going to get out.
Right.
You'd have to look. I mean, yes, you could say that you could look all the way back in the code and be like, okay, this is a power 5 or something like that. Yes, Colby.
But isn't that like a partially applied function?
Yes, that's a good example of a partially applied function. Yeah.
Okay.
So, yeah, I think you're right that at the end of the day, you wouldn't write objects like I'm describing. What I really think is that I just really like the way that OO and Erlang mix together. And I think that OO is more object-oriented than most people's object-oriented code or Erlang is more object-oriented than most object-oriented programs because everything, anytime you keep state, you have to have a separate module and you have to pass a message to it. And that feels way better than just having these monstrous objects.
I absolutely agree.
Yeah. And they encourage it. It's so easy to make a new module or a new actor.
That's cool.
And if you write OO code like that, you generally don't have to deal with some of the issues that you would with threading. Right? Like if you write good objects, they should be just as easy to thread as with functions.
Dependency injected, even objects that keep internal state, as long as the dependencies are injected, they could be run in any environment.
And you aren't running the single object over 2 threads, which is craziness. So.
Right, but if you wanted to run 2 instances of a dependency injected object on 2 threads with 2 different sets of data, you could totally do that. Cool. Anything else to say about functional programming? I guess here's my final question. If one hasn't gotten into functional programming, where should one start?
I think you should start by I think it was actually a training for work, but one of the guys who's like the crazy C++ guru, he said that somebody that was teaching him, when he would walk around and look at everybody's code, he would just point at variables and say, should that be const? I think the best place to start with learning how to write functional programming is to const everything. Always const unless you know it shouldn't be const. And that makes OO so much better. And then from there, once you get used to that, I think you can move into something like, I'm trying to think of what a good example is. I really like Haskell's pretty cool, but I would recommend Clojure, which is a Lisp. So it's kind of creepy at first, but when you look at it as just a bunch of functions that kind of you can like pick off the.
Yeah, my problem with Clojure, I tried to get into it, is that it's a JVM language and by definition almost impossible to understand what's going on. Like, there are so many things that aren't implemented in Clojure, and it's just like, oh, just use the Java class. And and how am I supposed to call this static function on this Java thing that I don't even know how to implement? It was weird. I'm a big fan of Elixir these days, which is at elixir-lang.org. It's kind of Erlang meets Ruby, another love of my life. But recently, beyond even the sort of syntactic sugar that they've added, they are wrapping and extending the Erlang OTP framework, which is this framework built into the language for doing things like a module that keeps state. It's called a server. Supervising processes so they don't die. All of this is actually, it's simple in a sense in Erlang because they already wrote it for you and it works and it's all generalized, and really all we're doing is writing a bunch of servers that talk to each other. But on the other hand, it's really obtuse because the syntax is weird and it was built for telecommunications in mind, so there's some weird terminology, but Elixir's taking a crack at not doing that, so kind of wrapping everything in a nicer way, and I think I'm really excited to see what the OTP stuff looks like from a usability, with a usability eye on it. So elixir-lang.org is my current choice. I guess I like Lisp as a concept, as a thing that you start with nothing and you build up all of your own stuff. So you could make Lisp into an OO language with mutable variables if you wanted to. It's terrifying, but it's pretty cool. And that's one of the reasons that Lisp isn't actually useful for anything, because it comes with absolutely nothing. And so...
But that's not entirely true, though, is it? It comes with everything you need to
build anything.
Most things, really.
Well, yeah, but if you wanted to, say, log out to a file, like, what is the Lisp way to log out? There is no Lisp way to log out to a file. There's 15 people wrote a way to do that.
That's true.
And like the Lisp, if you want to do, objects or Mapreduce in Lisp, there's 17 different ways to do it because it's not a language primitive. There's no standard library. There's
there is map and fold.
Yeah, true. There's no standard library.
Those are things that are absolutely necessary.
Yeah.
I have a somewhat unrelated question about Elixir.
Go for it.
Would you say that? Would you advise knowing Erlang before you do Elixir, or like that's? I don't know. One of the problems I have with like the compiled to JavaScript languages or the compiled to like CSS, the CSS preprocessor things, is that it's very easy to not know what you're actually doing.
Right. So Elixir doesn't compile to Erlang. It compiles to Beam bytecode, which is this VM, kind of like the JVM that Erlang also runs on. Mm-hmm. That being said, Beam comes with some assumptions that make it impossible to divorce. Like Beam was built for Erlang. It was never intended to really be used to run other languages. So there's some weird things that you kind of have to accept. I'm trying to remember what those are off the top of my head. I don't think, though, that you need Erlang. I think that Elixir is a standalone functional language, and at no point do you need to know that Erlang is underlying it. All of the error messages are native. It never drops you out into a Erlang stack. I mean, it is an Erlang stack trace, but it's an Erlang stack trace of Elixir code. So it makes sense. Yeah, I don't.
Because sometimes even in Clojure, you'll get Java stack dumps.
Right.
But I guess that's because it's running Java code. But
yeah, I don't think you need to know it. I think so. There are some. So if you want to use OTP, until very recently you had to know Erlang. In Elixir, you can call out to Erlang by basically prefixing the thing with a colon, and then you're writing Erlang at that point. Whatever that function call is, if it's the standard library or something like that. So a lot of the build tools are also written in Erlang, like the Elixir Erlang version of bundle or npm is written in Erlang. But you shouldn't need to know that to use it. It's just a command line thing at the end of the day.
Also, that's cool. I have another question if we're done with this.
Sure.
What's it like? What are good projects to start with?
For functional?
Yeah.
My favorite.
Or Dan, what do you use Elixir for? I don't know.
Okay, so what do I use it for? So my favorite functional, when I see something and I reach for a functional language, it's often when it's a command line script, because command line scripts easily have this referentially transparent property. It takes input and it outputs some stuff to the screen. That could be a compiler. It could be a thing that takes a CSV and ingests that into some other system. When you're taking in data and performing successive transformations on it until you get it into the form that you want, that's a really good time to use functional programming. I'm playing around with this system now in Elixir that doesn't work yet. It's a proxy. Yeah, I haven't told anyone about this because it's nowhere near done. But it's a proxy that sits and listens on the Minecraft protocol. I talked to you a little bit about this, Colby. So that when you connect to Minecraft, you can fire a callback before passing that request through to the actual Minecraft server. In this case, that would be to actually start the server before passing the request on.
So you can you don't have to be running the server until someone wants to play.
Right. Yeah. In that case, you ingest this stream of bytes. Streaming is a little funky in functional languages. I think Elixir ends up kind of with this I/O thing that probably Haskell has too, where you don't want to know really the underlying details of how reading characters off of a socket works. You just want to say, get me 50 bytes or get me until a new line from the socket. Get me that string, and then I'll be functional now. So that part's a little weird, but again, the Elixir, the dream with that is to be able to run a server node that handles all these proxies, and then many VMs beneath it that can spin up more Elixir clients that manage the Minecraft things. So
that sounds pretty cool.
That's specific to Elixir because it's really good at networked, distributed stuff. Tom, how about you?
For a starting functional, I personally think that writing a parser is a really good idea. I think that I know that sounds complicated, but it is the same sort of thing. It ingests data, right, and then it outputs it digested, and it also lets you learn how to do a parser. I think that if you're looking for a place to start, a cool place to start is I want to say it's like Haskell 100 problems. I think they have a bunch of them generally for a lot of programming languages. But if you do it in Haskell, you end up writing a lot of list transformations and cool math stuff.
Cool.
Sure.
Cool.
Yeah.
All right. Any other things to say about functional programming? Say it now or forever hold your peace.
Give it a try. Even if you don't use it daily, it will change the way that you write code.
That's a good point. Yeah, totally does. It'll make your OO code better. It has for me, at least. And with that, we're going to wrap up episode number 3 of the Change Mode. Please do not forget to go to coffeeandbeer.tv/giveaway. Enter the code FUNCTOR, which we, ironically enough, didn't end up talking about, but that's okay. It's a fun word to say. FUNCTOR.
Function objects.
Function objects. There you go. FUNCTOR, FUNCTOR as the giveaway code. And then coffeeandbeer.tv. Check out all the other shows in the network. They're pretty awesome. Thanks for watching, and we'll see you again next week or 2 weeks from now. We don't know. We'll see you again soon.
Thanks for having me on.
Anytime.
Certainly.
How are we doing, Sean?
This show is brewed fresh weekly by the Coffee and Beer Podcast Network. Get all our shows at our website, coffeeandbeer.tv.